All right, so just as a reminder of where we left off, we figured out the A, the C, the B. A is what's in front of the x squared, C is what's in front of the y squared, B is what's in front of the xy. And we said the cotangent of 2 theta equals A minus C over B. We got that the cotangent was equal to 1 over root 3. We flipped it so that it was become the tangent. So tangent of 2 theta was equal to root 3. We located that angle on the unit circle in our first quadrant, and it's pi over 3. And then 2 theta equals that. So we divided by the 2 and got that theta was pi over 6. So that's your first, and it's a super important step because it affects everything after it. But that is your first step. So if you started the WebAssign yesterday, there were angles on there that were not unit circle, well, values that were not on your unit circle. So I just took down the WebAssign because some of them were and some of them weren't when it regenerated new questions. So I just took down the WebAssign part and I put up a PDF that has questions that I've already worked out that all have the unit circle angles. The hard part, I think they're all pi over 4s. So you're not getting much of a variety, but I will try to find some extra examples to give you between now and Monday, because this is when that part of your test is. There's not a lot of rotation of the axis questions out there that are variations of unit circle angles, because there's only so many options you can get that are unit circle angles. So it is something that I'll work on trying to find some more examples for you. But the ones that I did repost are all unit circle based. So then we have our theta, and so we find x. To replace the x, we did x cosine pi over 6, y prime sine pi over 6, and then to replace the y, we did x prime sine pi over 6 plus y prime cosine pi over 6. And then we plugged in the values for all those over 6's, and we expanded, FOILed, simplified. We used the shortcut for the squares, and then we ended up getting it in standard form, which is the circled part on the bottom, which is x prime squared over 1. You don't need the over 1. Just remember that would make whatever that denominator is the 1. And then y prime squared over 4 equals 1. So that would be the second, like on your answer sheet for Monday, you're going to see the first thing's going to ask for the answer. It's going to be like one page. You have the whole page to fill. It's going to ask you for the theta. It's going to ask you for the equation in standard form. So if you do what we did yesterday, which was eliminate the primes while you're working, you want to make sure you pull them back in when you give me the standard form. And then it's going to give you a spot to actually graph the conic. So that's what we're going to do next. So what is this conic? What kind of conic would be an x? And if you want to graph it without the primes, that's fine. Just remember that, again, when you're doing it in standard form, you have to have the primes because this is an altered equation. It's not the same as the original. What kind of conic is this? An ellipse. What do we know about, because it's an ellipse because it's a plus in between and because it is different denominators. The other way that you can figure out your ellipse is once you eliminate the x, y term, which is here, like on that line, you can use your classification test. You can look for your A and your C, and you can use that process. So because these are both positive, the sum of the multiplication of them or the product of them would also be positive, that you can also classify from there. So you don't have to wait till you get to the end to classify it, but you have to wait until the x, y term is gone. So you cannot classify it from here, okay? Sometimes it works, sometimes it doesn't. You have to wait till you eliminate the x, y term to classify it using the AC relationship. All right, so we know it's an ellipse. What kind of ellipse is it? Vertical or horizontal? Vertical, because the larger denominator is underneath the y. And that larger is your a squared. So a squared is 4, a is 2, b squared is 1, and b is 1. What's my center?
0, 0.
Good. So now when I go to graph it, so on your test, you'd be provided with just a regular coordinate grid. The first thing we have to do is rotate the axis. So theta, remember theta up here, is pi over 6, which means we have to rotate the axis to pi over 6. Now this is not going to be an exact science, right? But pi over 6 is like 1/3 your way from the x-axis to the y-axis. So you're gonna, and I would recommend using a straight edge, whether that's your ID or if you have a ruler at home. If you're here, I'll pull out rulers. I would recommend using a straight edge so that you get that x-axis that's rotated. This is my x prime axis. And then you can turn it at this point, but you want to turn it so that you find your perpendicular axis. Oh, I need to group it, sorry. Told ya. I said Jacob will be here.
I woke up late, I had to do your project.
So I pause it. I drew the y-axis perpendicular to the y prime axis perpendicular to the x prime axis. And now I'm going to use this to graph all the information about the ellipse I just found. So my center is 0, 0. Your tick marks on the right, left, up, and down are your tick marks, so that you have to space them however it is you're going to be. Just make sure that you're consistent. So if this is my 1, 2, 3, 1, 2, 3, make them about the same size. Obviously, it doesn't have to be perfect. I don't want you to take out a ruler and measure it, but don't make one teeny tiny and one huge. Be consistent. And then I'm going to plot my A, because this is vertical, is going up and down. So that's my vertices. And then my B, which is horizontal, is going right and left, which is 1, yep. Let me get a different color. And that is your, that is your covertices, and then it's an ellipse, so we just connect them. So because you're doing this on paper, obviously when you're doing it on your homework tonight, you're on your iPad, you could just turn it like we do digitally. But if you want to practice it on a piece of paper, because that's what you're going to do on Monday, then take your piece of paper, literally rotate it, draw your axis, and then when you turn this into me, it would be back its normal way. So this would be an ellipse that's rotated pi over 6. You remember doing something similar to this?
Something similar to this, but not exactly, because I remember last week we did it with like a sticky note. We rotate the sticky note.
I don't know what that is. In math?
Yeah, math.
I kind of remember.
We did something like that.
But like last year was kind of fun.
I know, but that's all I remember from last year.
This is what we had filled out the other day. What, Monday? Yeah. So this was my circles and parabolas. This is my ellipses. We did the hyperbolas. And then I said to leave that last page blank, right? So this is that last page. The top part of this, the classification, will be on Friday's portion. You're going to get a question. It's just one. But one question that says to classify the conic. And then the rotation of the conic, the thing below it, is what would be on Monday's portion. So let's at least fill out this top part. Okay, actually we'll fill out the whole thing because we're not going to have time to review it again. Okay, so remember that the A is what's in front of the x squared and the C is what's in front of the y squared. If our A and C are equal, what kind of conic is it? It's a circle. If the product of our A and C is 0, what's our conic? So close. Parabola. Because what does it mean for it to be 0? Like for a product to be 0, one of them has to be 0, right? Yeah. Which means you don't have an x squared or a y squared. So you only have one squared term, which is a parabola. If it's positive, if the product is positive, and they're not the same, right? Because you want to make sure that are they the same first, it's a circle. But if they are positive and not the same, now it's an ellipse. Good. And if it's negative, it's a hyperbola. So especially because you get this reference sheet or whatever kind of reference sheet you want to create on your test, this should be an easy 5 points, okay? Every year somebody screws it up and I'm not even sure what they're doing in their head that makes them screw it up, but they'll screw it up. Don't be that person.
Wait, how do you find this video?
You already started it on Monday.
Oh, that one?
Yeah.
Okay. I thought it was a different one, that's fine.
Nope.
Did we learn this on Monday?
Yep, well we didn't do this slide.
I thought it was a different one. That's
We
fine.
learned it on Monday. Oh, you weren't here.
How was this?
Yeah.
Is there a video on it?
Yeah. Yeah. So we went over that on Monday, and I had them fill out the rest of this review up to this point. Okay, so then comes the rotation of the conic. So if you want to draw yourself a little note of a reminder that this is Monday's portion.
So Monday is just rotation?
It's just rotation. It is literally one question, but it's 25 points.
It's like a quarter of the entire test.
Well, it's only 3 sections of yeah.
But you can get like.
You can get partial credit, of course, yeah. So the finding of the angle is the first step, right? So cotangent of 2 theta equals A minus C over B. And that would give you partial credit. I haven't figured out how I'll divide up the points, but that's not going to be a huge chunk of it, but it will be.
We have one more test after this.
Yeah.
We only have one more test.
No, you have 2. The
Oh.
seniors have 1 more. You guys will have 2.
Because of that test. So we leave it out because we're not having fun with it.
And the y, right? And those equations are given to you right on the test, but you can write them down as well. The x is x prime cosine theta minus y prime sine theta. And the y is x prime sine theta plus y prime cosine theta. So I will also show you that, I think I worked them out both ways on the homework when I'll post the solutions after it's due. But you can actually plug those values in before you do that full formula. So again, I'll kind of show you what I'm talking about in a second. But there's 2 ways I would say to plug in that information. One is as it is, it's formula, then do the angles. The other is do the values and then plug it in. So 3 says plug x and y back into the original equation and get the conic into standard form. That's the part that's super tedious, long, and not fun. And then 4 is rotate the axis and then graph the conic. So it's not like you're going to have to provide to me the individual, like the graph will show the coordinates, but because they are rotated coordinates, like you can't find those exact points. You can, but it's a longer process than you could be able to do right now. So you're just going to approximate it.
How many questions can be in the entire test? Like together?
There's 10, I think. There's 9 on Friday's part, and then 1 on Mondays.
Oh, that's weird. Okay, good. At least
I
one
think
has-
that's how it
So-
breaks down.
On Friday, are they all grafting?
No, Friday there's a graph for each conic, but then and then there's the reverse. Here's information, give me the equation for each conic, and then there's classification. So I gave for the part 2, just because some of the numbers are bigger on the coefficients, I gave the basic calculator on lockdown if you want to use it. You know, like yesterday, it'd just be simple like multiplication, but if you want to use it for that, that's fine. But there will be no other calculators. So there will be no graphing, no scientific, no other calculators on either portion of the test. You definitely don't need it on Friday's portion, but I gave it on Mondays just because I don't want anybody to complain that their numbers are too big.
The numbers are going to be big.
They're going to be bigger than 2 and 4, yeah. And I don't want the multiplication to be what hangs you up on your time. All right, questions? Okay, so I'm going to open up the PDF. That was the homework that I assigned yesterday so that I can show you what I was talking about. So in this section, you would also use that unit circle first quadrant. So I would include it. Either take a picture of your unit circle or draw it out real fast. You only need first quadrant. 0, pi over 6, pi over 4, pi over 3, pi over 2. Add the coordinate points. So 1, 0, root 3 over 2, 1/2, root 2 over 2, root 2 over 2, 1/2, and root 3 over 2. 0, 1. And then I would add the tan. So this is my sines and cosines. Obviously the x equals your cosine. The y equals your sine. And then the tangents. Do that in a different color. This is 0, root 3 over 3, 1, root 3, and undefined. So you're going to use that to not only figure out what theta is by using the 2 theta equals whatever the value is, but you're going to also use it when you plug the values into your equation of the sine of theta and the cosine of theta. When I talk about the rotation. And I'm going to show you, I'm going to get you to a certain point, then I'm going to say this is what I would say. You have two choices, and then from there I'm going to let you work. So if you look at 77, the first thing that we want to do is identify the A and the C and the B so that we can figure out what the angle is, right? So what's A? 5. B?
5.
Nope.
Oh,
Negative 6. C?
Negative 12.
Nope. 5.
What?
A is in front of the x squared, B is in front of the xy, C is in front of the y squared. So cotangent of 2 theta equals A minus C over B.
Oh, I wrote the question down wrong.
Oh. And you get 5 minus 5 over negative 6, 0 over negative 6, which is 0.
flip it.
So now I'm going to flip it. Tan 2 theta,
Is equal to
undefined.
and that's pi over 2.
Good. So 2 theta equals pi over 2.
Theta is pi over 4.
Divide by 2. Theta is pi over 4.
Really fast.
It's the same that we did, right? And guess what? All of these are that.
They're all
Yeah,
the same.
I'm working to find you some examples, but it's really not fun. The numbers get to be ridiculous. So, but I'll find you some because I'll put it on the review.
Well, thank you.
You're welcome. Because I can't obviously give you the same ones that are on the test, but the tests are not all pi over 4.
Oh,
They have to be in the first quadrant, yeah. Okay, so now comes the xy part.
yep.
So x equals x prime cosine theta minus y prime sine theta. And y equals x prime sine theta plus y prime cosine theta. So here is your choice. You could literally take those full expressions, obviously replacing the theta with the pi over 4.
It'd be root 2 over 2.
Yep. Or you could actually figure out those values before you plug it in. So I could say x prime cosine pi over 4 minus y prime sine pi over 4.
That's just x.
And pi over 4 is root 2 over 2 and root 2 over 2.
Oh, x prime.
So I could make this root 2 x prime over 2 minus root 2 y prime over 2. So you have two choices of what to plug in for x. Either with the angle and then plug in the value, or you could plug in the value and skip that last step.
So you don't have to write it all out. Like,
It eliminates a little bit more of the writing out. Like you don't have to write out cosine, sine, cosine, sine, cosine, sine. But you still have to write out the rest of it.
but it helps.
And then y x prime sine of pi over 4 plus y prime cosine of pi over 4. Or y equals root 2 over 2 x prime plus root 2 over 2 y prime.
Is this the
No.
Oh, wait.
This, when you plug this in, that's when you determine that. And when you do the xy, it's going to happen. So this 77 has both shortcuts. So I'm going to write out both the ways to plug these in. Don't follow both. Wait until you figure out which one you want to do and then do it, okay? So if I plug them in as we did yesterday, it would be 5 x prime cosine pi over 4 minus y prime sine pi over 4 squared minus 6 x prime cosine pi over 4 minus y prime sine pi over 4 times the y, which is x prime sine pi over 4 plus times, I didn't finish that, plus y prime cosine pi over 4 plus 5 times, yeah, all right, so now I'm at this part, right? I just did this one, 5y squared, and then it's a minus 12 equals 0. So that is one option. And then to go from there, I would plug in the values for the cosines of all the pi's over 4s, the sines of all the pi's over 4s, right? Your other option is if you plug in the values before you plug in the expressions, then I can write this as 5 root 2 over 2 x prime minus root 2 over 2 y prime squared minus 6 x, which is that same thing, root 2 over 2 x prime minus root 2 over 2 y prime times the y, root 2 over 2 x prime plus root 2 over 2 y prime plus 5 x, root 2 over, this is the 5y, so root 2 over 2 x prime plus root 2 over 2 y prime squared minus 12 equals 0. So again, how you choose to do that is up to you. It really only eliminates like the repeating of the sine and cosine. Everything else is pretty much just about the same amount of work. Because from here, like this step would have come after that step. But if you choose the first method, you don't have to do this step. With me so far?
Yes.
Now comes all the foiling and expanding, right? This one, in this example, you actually, which is going to happen on the pi's over 4s with the x squareds, y squareds, and xy's, you actually have all of the shortcuts happening. The one shortcut where it's a binomial squared, and the other shortcut where it's the difference of two squares. Now, I would say as you're working through, feel free to lose those primes because they kind of get in the way and it's an extra thing that you're writing all the time. Just remember to make sure you bring them back at the end. You're so smart. Okay, so the 5 and then the root 5, a root 2 over 2 x prime minus root 2 over 2 y prime squared. I'm going to ignore the primes, okay, and I'm going to do the squared. So 5 and then square root of 2 over 2, that becomes 2 over 4. And I'm actually going to leave it as 2 over 4 instead of simplifying it. In a little bit, you'll understand why. So 2 over 4 x squared. Then find the product here. Root 2 over root 2 over 2 times root 2 over 2 is the same thing as squaring it. I get 2/4, but I want to double it, so it's actually 4/4. And there's a minus there because one would be positive and one would be negative. X, y. Then I square the third one, and I'd get again, this time it would be positive, 2 over 4 and y squared. Then I go to the purple, minus 6. And this time, what are these two parentheses? Good, same but different sides. So this is going to result in the difference of two squares. This only happens with a pi over 4 with an xy. Okay? It doesn't happen with a pi over 3. I mean a pi over 6, pi over 3. It only happens with a pi over 4. So I can use the a squared b squared shortcut, which says this would be root 2 over 2 squared again, which is 2/4, x squared, minus root 2 over 2 again, which would be 2/4, y squared. Then I go to the red, plus 5, and again it's a square, so I get to use that shortcut. Square the first one, we know this now, it's 2/4 x squared. Multiply the two together, 2 over 4, double it, it's 4 over 4, but it's a positive, xy. Square the last one, again, square root 2 over 2, which is 2 over 4, y squared. Minus 12 equals 0. Now all the denominators are over 4, so I can get rid of them by multiplying my entire equation by 4. So from all of the parentheses that have all the 4s, it completely cancels out. Cancels, 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 cancels. The 12 over here gets the 4, however, and obviously 4 times 0 stays a 0.
Are the denominators always going to be like...
If you keep them over 4, they will always cancel, okay? And that's one of the reasons why I say keep them over 4. When it's a root... Yeah. If you don't simplify them. So like if you simplify them, sometimes they simplify to a half or something over 2, and sometimes they don't, and it would be kept over 4. So that's why I say keep them all over 4, and they will always cancel out. Because no matter what point on your unit circle, your denominators are both always 2. So whether it's root 3 over 2 and 1/2, it's root 2 over 2 and root 2 over 2, or 1/2 and root 3 over 2, the products are always going to be 4 on the bottom. Does that make sense? And that's why I say don't simplify. If you simplify, sometimes they're 2, sometimes they're 4, and that's where it gets a little bit tricky. So I wouldn't simplify so that one step can be done and get rid of all of them. Okay, so I'm going to do the next step together. I'm going to distribute, rewrite and distribute. So I'm going to distribute the 5 here and rewrite that line instead of having to do it twice. So 5 times 2x squared would be 10x squared. 5 times negative 4 is negative 20xy. 5 times 2 is 10y squared. Do this slow and carefully. Like, I know from personal experience that this is the step, I don't know why, I tend to mess up my signs and then it goes all wrong. So just be careful. Then I'm going to do the 6 into both. So minus 12x squared, and this is the step I tend to mess up. Like the negative times the negative, I forget. Obviously it's a positive, 12y squared. And then 5 into all 3 of these, positive 10x squared, positive 20xy, positive 10y squared. And I'm going to bump the 48 to the other side just because I know it's going there eventually anyways. So it's a negative 12 times 4, which makes it a negative 48. And then when I bump it to the other side, it becomes a positive 48. Now, we're going to combine like terms, but we're going to look at the x, y ones first because the x, y ones have to cancel, and this is where you can catch a mistake. If the x, y ones don't cancel, then you did something wrong. So I've got a negative 20xy, and a negative 12x, nope, I underlined the wrong one, and a positive 20xy. They cancel out. So at least I know that part's right. If that does not cancel out, you did something wrong already. Now I'm going to group together the x squareds. There's 3 of those. 10 minus 12 is negative 2, plus 10, right? 10, yep. Minus 12, negative 2, plus 10 is 8x squared. 10y squared plus 12y squared, 22, plus 10, 32y squared equals 48. So because we've already eliminated the xy term, you can look at this and figure out classification-wise what kind of conic it is, which is what? It's an ellipse. Good. The A and C are not the same, but the product would be positive. Does everybody understand? Yeah. So you can do it here, or you can keep going. The benefit of doing it here is if it's a circle, you would do it differently. If it's an ellipse, what does it have to equal? 1. So I'm going to divide everything by 48. So how many times does 8 go into 48? 6. So this is x squared over 6. 32 does not go evenly into 48, but what are they both divisible by? 8. So this would be 4 and 6, and then I can go one more time, right? 2 and 3. So this would be 2y squared over 3 equals 1. So when I was talking earlier about fractions in your actual equations, you can't leave the 2 where it is. There can't be anything in front of that y squared. So that 2 becomes the denominator of the denominator. So this would be x squared over 6 plus y squared over 2/3 equals 1. And then don't forget to add the primes back in. Now that's standard form. So from here, you're going to graph your ellipse, and I'm going to let you do this on your own, okay? You're going to find your center. You're going to figure out if it's vertical or horizontal. You're going to find the square root of 2 over 3. You're going to totally approximate that. If it is less than 1, then your square root is also less than 1. And then just mark your, rotate your axis, do the tick marks, and then draw your ellipse from there. But I want you to do that on your own since we just did the last one with you. All right, so you've got about 13 minutes, and I would say you have two choices right now. One is finish the rotation of the conic. I would probably lean more towards that. So finish this. The other is if you already started this or did a lot of work on this, then you can also work on your chapter review. So you want to look through the chapter review as much as you can. This homework's due tomorrow, but I would say because you only have 2 questions left, you would also want to look through that chapter review so that tomorrow in class I can answer with questions on things that you are feeling like you have holes or gaps in. Because this is on Monday's portion, but the rest of the review is on Fridays. Everybody's good? Yes? Questions?